In this video, I'm going to go over how to solve the last two questions from the lesson on solving exponential equations. So just to recap a few questions from here. So part E. So for part E, this one is a little bit more difficult than the other ones that we have looked at in class, the other examples. So for part E, what you need to do first is you need to separate 4 to the exponent of x plus 2 and write it in terms of two powers being multiplied. So 4 to the exponent of x multiplied by 4 squared. You would also want to change the 16 to the exponent of x. You would want to change it to 4 to the exponent of 2x. So change the 16 to 4 squared. And after doing that, you probably will notice that we have now something that resembles a quadratic. And what we want to do is we want to move the 4 to the exponent of 2x to the right side actually of the equation to make it positive. We're basically moving everything to the right side of the equation. So if we do that, we get positive 4 to the exponent of x squared minus, so 4 squared here becomes 16, and now it's negative because it got moved to the right side. So negative 16 times 4 to the exponent of x, and 64 stays positive because it's on the right side. And so now we can use replacement. We can replace 4 to the exponent of x with a, just to make this easier to look at, turn it into a simple trinomial. We can factor this simple trinomial. It's a perfect square trinomial. So it ends up being a minus 8 squared is equal to 0. We square root both sides and end up with a minus 8 is equal to 0. Move the 8 to the other side. Bring back the 4 to the exponent of x. So we have 4 to the exponent of x is equal to 8. Change the 4 to 2 squared. Change the 8 to 2 cubed. Drop the bases now. Equate the exponents. And we end up with x equaling 3 over 2. Now for this thinking question here, nothing particularly special about it. What you want to do is you want to find what the common base is. The common base is 2. So 8 turns into 2 cubed. And we're going to multiply the 3 and the x squared together. And then the 4 here turns into 2 squared. We're going to have to distribute the 2 and multiply negative 5x and 4 by the 2. And so once we do that, we get 2 to the exponent of 3x squared is equal to 2 to the exponent of negative 10x plus 8. We're ready to drop the bases. Get 3x squared is equal to negative 10x plus 8. We move the negative 10x and the 8 to the left side. We get a simple trinomial, or actually not a simple complex trinomial because a is not 1. And so we factor the complex trinomial by using the crisscross method. So two numbers that multiply to 3, 3 and 1. Two numbers that multiply to negative 8, negative 2 and 4. They're aligned this way. 3 times 4 is 12. 1 times negative 2 is negative 2. 12 plus negative 2 is 10. So the way they're aligned currently works out. So that's our first factor. Second factor, just a matter of adding x to each one. So we got 3x minus 2 multiplied by x plus 4 is equal to 0. We solve each factor, right? So we set each factor equal to 0 and solve for x. We get x is equal to 2 over 3 and x is equal to negative 4. All right, so now looking at part B of the thinking section, this one is a little bit different than the other examples that we've looked at so far. So here what we would want to do is we would want to change And so change the bases so that we can get a common base. Now it's actually fairly easy here. We don't actually have to really change the bases. We just have to change the 1 over 4 to 4 to the exponent of negative 1. And then what we can do is we can drop the bases from that point on. And we end up with one equation already. So we get a linear equation. Now we want to do the same thing for the second equation. So 4 to the exponent of 2x minus y is going to equal 4 squared. We can drop the bases at this point and get 2x minus y is equal to 2. That's our second equation. Now what we can do is we can take our first equation and write it under our second equation. And now we can use elimination. We can subtract the two equations. And we're going to end up with x is equal to, so 2 minus negative 1 is going to be 3. So x is equal to 3. Now in order to find y, we just have to substitute into one of the equations. We can use the first equation. So instead of writing x, we're going to write 3. 3 minus y is equal to negative 1. So that means y is going to equal, well, negative y is going to equal negative 4. And so if we divide both sides by negative 1, we just get that y is equal to 4. And so that's what y is equal to. And so now we can state what the point of intersection is. Therefore, or solution to the system as well. So yeah, let's just say POI. The POI point of intersection is 3 and 4. So that's the point where the two in this case, well, lines will intersect each other. Okay, and so that is our solution. So now let's look at this last thinking question. This comes from the Waterloo courseware site. So it could potentially be a math contest question. So it says determine the x-intercept of the function g of x is equal to 12 times f of x minus 6, where f of x is an exponential function of the form f of x is equal to a times c to the exponent of x, where a cannot equal to 0, c has to be more than 0, c also cannot equal to 1, such that f at x plus 2 minus f at x plus 1 is equal to 12 times f of x for all x belonging to the set of real numbers. And we also know that f at negative 1 is equal to 32. So a lot is given to us, a lot of information here. So how would we start this? We have to first look at what's given to us here. I think that's what you want to start looking at. And so it's function notation. Now in terms of the function that we have here, f of x is equal to a times c to the exponent of x. So we can go off of that. And so if we use function notation, we're going to have a times c, and we're substituting x plus 2 in for x. Okay, and then f at x plus 1, we're going to have a times c to the exponent of x plus 1, close bracket, is equal to 12 multiplied by, so I'll just write a times c to the exponent of c to the exponent of x. Okay, so all that I have done is I basically used this statement here, right? So I looked at my function, which is this function here, and I substituted in for x. I substituted x plus 2 in for x, which is here, and I substituted x plus 1 in for x, and I got this. Now, in terms of what we can do with this, right away we can actually cancel all the a's out. We can divide everything by a. And that's going to simplify things. So we're gonna get c to the exponent of x plus 2 minus c to the exponent of x plus 1 is equal to 12 c to the exponent of x. Now, what we can do next now is we can change this and write it as c times c squared minus c to the exponent of x times c to the 1 is equal to 12 times c to the x. And what we're going to get from this is so what we can do is we can factor out a c to the x, and we get c squared minus c is equal to 12 times c to the x. And we can actually divide by c to the x. And we'll get that c squared minus c is equal to 12. This is a quadratic. So c squared minus c minus 12 equals 0. We can solve this by factoring c minus 4 multiplied by c plus 3 equals 0. So it's just a simple trinomial. From this we get that c is equal to 4 and c is equal to negative 3. Now we're told that c has to be more than 0. Right? We're told that here. So that means that we would have to exclude c is equal to negative 3. Okay, we would have to exclude this value. So c would have to equal 4. So now we know what c is. So if we go back to our equation that we have for f of x, we have f of x is equal to a, and now it's going to be times 4 to the exponent of x. We have our base now. Now another thing we know is that f at negative 1 is 32. And so now I can solve for a by substituting in. So I could do f at negative 1 is equal to a times 4 to the exponent of negative 1. Now I know that f at negative 1 is 32. So 32 is equal to a, and then this can be written as 1 over 4. 4 to the exponent of negative 1. So if I multiply both sides by 4, I get 32 times 4, which is 128. So 128 is equal to a. Okay, so that's important to know. So now we know what our function is. Right? F of x is equal to 128 times 4 to the exponent of x. That's f of x. So what do we want to find next? We want to find the x-intercept, right? X-intercept of this function. Okay, so we know f of x. So let's write what g of x is. So g of x is 12 multiplied by f of x. So 12 times 128 times 4 to the exponent of x minus 6, I believe. Yeah, minus 6. Now we want to solve this for x. So we want to solve for the x-intercept, right? So we would have to set y equal to 0. Okay. Now we have 12. So we can multiply this out. So 128 times 12. So that's going to be 6. Right, we want to remember the 1. So 2 times 2, 4. Remember the 1, that's actually 5. 2 times 1, that's 2. And then 1 times 8, so 8. 1 times 2, 2. 1 times 1, 1. 6. 13, so remember the 1. That's going to be 5. And then 1. Okay, so it's quite a big number. So 1, 5, 3, 6 times 4 to the exponent of x minus 6. And so now we have 6 is equal to 1, 5, 3, 6. We're trying to solve this now for x. Okay. We want to divide both sides by 1, 5, 3, 6. Okay, and so we want to see if this is actually divisible. So let's check if it is. I'm just gonna use Desmos for this. Oops, where is Desmos? So Desmos. Oh, it's actually open already. Yeah, it's taking a while. Okay. Or maybe just long division could work too. It probably is divisible. 1, 5, 3, 6 by 6. So how many times does 6 go into 15? This is a good review of long division. Twice. And we get 12. Subtract. We get 3. Bring down the 3. How many times does 6 go into 33? 5 times. So 30, subtract, we get 3. Bring down the 6. How many times does it go in? 6 times. 256, so not too bad. So 1 over 256 is equal to 4 to the exponent of x. Now, 4 to the exponent of 4 should be 256. So we write this as 1 over 4 to the exponent of 4 is equal to 4 to the exponent of x. Then we get 4 to the exponent of negative 4 is equal to 4 to the exponent of x. And so So that means that, well, x is equal to -4 then, would be the answer here. Okay, so that is going to be the x-intercept here. You can write therefore statement, therefore the x-intercept of g of x is -4. All right, well, that is the end of this lesson. And I'm going to post another video on solving logarithmic equations for that lesson as well. So make sure you watch that as well. Thank you for watching and have a good rest of the day.